Hey everyone, I'm Megan McGuire. I work at Desmos in partnerships with a focus on assessment and our B2B work. I'm really excited to be here today. And Joel, it's really nice to see you again. Excited to dig in with you all.
And my favorite fun fact about Megan is that we first met, man, I want to say like 6 or 7 years ago. She was at the College Board doing a number of really interesting, innovative things around assessment, and chief of staff to their chief operating officer. And after that first meeting, I turned to my colleague and I was like, oh my God, I cannot wait to work with Megan. The rest of the folks at the College Board were also like pretty great, but like Megan was the one who stood out for both of us, where we're just like, yeah, she's the one. And so now we do it. It's the best.
Here I am. We're here.
Yeah, so Megan and I are kind of the two-headed monster, thinking about everything around how we can work through partnerships to get Desmos into more hands. And I'll talk a bit about some of the straight-to-consumer and then straight-to-school work that we do as well. What version of LTI are we using? We have used some LTI, I believe, LTI 2.0. I admit I'm not actually all that familiar with that integration, and it's just around our activities and just with 2 partners. There is not currently an LTI calculator integration, which I think is a place where we could possibly collaborate very effectively. So a little bit of background on Desmos. We launched in 2012, incorporated in 2011. And it came out of some work that I did when I was in college, actually as a tutor. So my story is that I went to Yale University and paid my way through college largely by tutoring the sons and daughters of scions in Westport, Connecticut in math and physics, where they would pay me ungodly sums of money to come hang out with their kids who were all going to be fine anyway. And I also volunteer tutored in the New Haven public schools. And this was the first time that I felt so viscerally in my life. 2 different things. One of them was just the enormous gulf of inequity between these populations that I was working with in a way that just really kind of disgusted me. And the other that also disgusted me, it turns out Desmos was born of disgust, was that kids were still spending $100 for technology from 1996. And you follow Moore's law, and every single other place, something like the handheld calculator should have cost like 8 cents at the point at which kids were buying them. And instead it's this same kind of hardware that you're paying a premium for it to not do much. Like that's actually what you're paying for because of all of the requirements and the monopolistic tendencies they had. And so we're thinking every kid has a much more powerful computer in their pocket than one of those calculators. What would it look like to design something for that so that it can take advantage of this technology, make it free, change the business model, flip it on its head, and put this out there? And I built it originally for the kids that I was tutoring in Westport and in New Haven. Me and one colleague, this is actually back even before we incorporated, my colleague Mike, who is still at Desmos, absolutely wonderful engineer who I met on a forum, rentacoder.com. I was a junior in college. He was a junior in high school. We both thought the other person was like a totally legit human. He thought I was like a savvy businessman wearing a suit and a tie. I thought that he was an adult. He was instead a 16-year-old living in his parents' basement. And it took 4 years for us to disentangle that. That was when we first met and realized that neither of us was who the other one thought that we were, but we still worked together about a decade later, which is a total blast. So the 2 of us put together this calculator, put it up on the Chrome web store. One of our other thoughts was we wanted to see how good of a product we could make with JavaScript, which this is before Chrome came out. So this is back when JavaScript wasn't kind of in vogue in the way that it is now. And thinking about how good of a job we could do with that. So we put it up in the Chrome web store. We were one of the first apps in the Chrome web store since, long since deprecated the Chrome web store is. And yeah, it kind of took off. Like in the first week, we had hundreds of people using it, which to me was just an absolutely mind-numbing number. Like that I couldn't shake hands with every single person who was using the calculator that week, just completely blew my mind. Since then, in the subsequent 8 years, last year we had about 50 million people use the Desmos calculator. We had about 40 million in the United States. So it's been just kind of wild to see how much of a need that there was for this product. That's a little bit of the backstory. And so we launched early 2012. And over the subsequent 8 years have been focused on 3 different efforts in parallel. So one of them is getting the calculator into just everyone's hands who can have it. A second one is getting the calculator onto every high stakes assessment that we can, because this was the reason that Texas Instruments maintains its stranglehold, is that it's what you can use on the SAT and the ACT and on state exams. The fun fact on that front, and a lot of this is credit to Megan and her team, we're now built into the SAT, the ACT, and the state exams in 38 states, as well as the International Baccalaureate. And so that one's working. The result of the combination of those first two efforts is that internal reports at Texas Instruments say that we've cost them over $400 million in revenue over the last few years. So eat that, Texas Instruments. Unfortunately, not all of that $400 million came to Desmos. Most of it went back into the pockets of families in the United States who need it even more than we do. So that's two of our efforts. And then we've also been building out a comprehensive middle school math curriculum. And I'm going to give you a little bit of a peek at that using some new technology, which we're not yet packaging up as an API for folks to license. But we actually intend to sometime in the next year, and there could be some interesting opportunities there. That's just kind of the rapid fire. Here's how Desmos got to where it is. Oh, a couple more stats. We've got about 50 employees on our team. We're spread out around the world. Our furthest one is in Australia. We've got just hired someone in Canada. We've got someone in, I think, Colombia. And then the rest of the team is spread out across the continental United States with 3 folks in Hawaii. We do have investors. We've taken on a little bit of investment money. Most of our funding comes out of revenue from partnerships. And so someone asked here, how do you keep Desmos free? And there's 2 different answers for that. We do have a business model. I love this question, by the way. I think people should ask this of companies in education, like way more often than they do, because there's basically 3 possible answers, which are we have no idea, and at some point we're going to run out of money, like don't depend on us. We have a business model. And I'll share that one in a bit. I love the fact that you folks fall into the second category. And the third is we have a business model that we're not that proud of, and it probably involves advertising or selling your data to someone against your will. So we're in that second category. Our revenue comes from 2 different sources. For our calculator, it's API partnerships. And so I think there are some interesting opportunities together around licensing Desmos's technology and then selling it. And so we've got about 60 plus customers who we work with in that capacity, Pearson, McGraw-Hill, the College Board, the ACT, a number like that. We also, the curriculum is a paid curriculum. This one is much more new. We just launched it last year, but schools pay us on the order of $15 a student a year to have access to our comprehensive curriculum. And so all of that adds up to Desmos being able to take the vast majority of our work and put it up for free on our website and hopefully serve tens of thousands of teachers and tens of millions of students every month.
I kind of wonder what your, well, this could be a later question, but what your typical partnership relationship looks like in terms of technical integrations.
Yeah, it's a great question. And I wish that it had a really simple answer. It doesn't, because we have slightly too many products. But generally what it looks like is folks will use our calculator APIs, which is our graphing, our scientific, and our 4-function calculators, and then self-host, integrate them into their system, upgrade on a biannual upgrade cycle with us, and then sell a product and pay us per student that uses it with some kind of base integration annual fee. So that's how most of those partnerships work. And then there's varying levels of complexity within that. Folks can build more or less advanced products. Here was our premise, was we wanted to start with the idea that anything that you could do on a handheld calculator, you should be able to do in a browser, but just much more easily. We've got this company value of works every time, which is just whatever you do, if we can understand it, we try to understand it. And so for something like y equals x, this is really straightforward. But since we're on a computer and it's got just hella pixels and really good processors compared to a handheld calculator, we can do things like respond to every single keystroke. So I change this to y equals 2x, and it immediately updates the graph. And there's some great research. We didn't do this because of the research. We didn't even know about it until after. But about how the expediency of the feedback loop and the connectedness of representations makes a huge difference for how quickly you're able to understand and comprehend the mathematics. And so here, being able to see these side by side and having it update with every single keystroke lets you have insights that are just much, much harder to have if you need to keep all of that context when you switch views. So this is where we start, and we wanted to make it so that you could do any kind of graphing that you could do on a handheld calculator. So I know that the question here was, what can you do beyond plotting points and plotting curves? But we're going to start by plotting points and plotting curves. So here, I can also plot a point. I can do something like 2, 3, and it will place that point here. It understands things like trigonometric functions, y equals sine of x. All of this, again, is going to update as I'm typing, so I can do this kind of thing. There's a built-in keypad that shows the different functions that we support. And so it can do all of the basic stuff that you'd expect, but it can also go past that. And so I can do a parabola, of course, like this, but I can also do things like Fourier decomposition. I can do the sum from 0 to 10 of, oh man, what is this going to be? It's going to be something like x to the n over n factorial, and this is going to give us an approximation of an exponential curve, so I can then see how this approximates e to the x. I can take this, and I'm actually going to leave this graph behind for a second. We're going to come back to it. All of the places that you can use numbers, you can also use parameters. And so here, instead of doing y equals 2x, I can make this y equals mx. It doesn't know how to plot it because it doesn't know what m is, but I can make m a slider. I can drag m, and now I can see all of the different possible variations. And this works not just for this kind of parameter, but for any kind of parameter that I want. So for example, in here, I'm going to try making this actually a little bit more interesting. I'm going to do -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. I believe that this should give me something that looks like a sine curve. And indeed, if I plot this, it looks like a sine curve. And I can come into here, and I can also parameterize, for example, this upper bound. And so I can make this one n. I'm going to say that n can be anywhere between 1 and 10 by 1. And now I can watch what happens as I add successive terms to this Fourier decomposition. Or I guess this one is a Taylor decomposition, sorry. So the goal here was to make it so that anything that you wanted to do at kind of any level of mathematics, you can explore it instead of just seeing it. And you can explore it hopefully relatively straightforwardly. Not that the math here is straightforward by any means, but if you know what you want to express to the computer, then the computer is able to understand it and work with you as you do it. A gargantuan amount of work has gone into making it so that it can do this performantly. I'm sure that for the engineers on this call, you can imagine that making something that is this smooth is a heady task. I wish that I could tell you how we did it, but it is actually beyond me. But really powerful. Okay, we can actually do one step better than this if we want to. So coming back to here, I've got this y equals mx, and it's plotting this curve. Instead of just having this curve be a single value, you can also have it be a list of numbers, and then it will treat all of them as independent branches of the same graph. And so here I can do something like 1, 2, 3, 4, and I can see all of those plotted at once. I could do this with shorthand, so I can say I want it every value between 1 and 10, and it's going to plot all of those. And now if I change it to 100, it's going to plot all of the curves up to 100. And coming back, I can apply that here as well. So I could have this be n is 1 through 10, and it's going to plot all of the different Taylor decompositions of this sign. So everywhere that you can use numbers, hopefully you can also use lists, and you can use this as a way to do some really, really fun math. Just for fun, I want to show you a couple of the features that we released last week that let you go even deeper than this, where you can also make the different styles of these curves depend on this list as well. So I'm going to open up the style menu for this, and I'm going to make them all a little bit thicker just so that we can see. So those are all of the decompositions. And I'm going to make the opacity of these depend on which branch in that list it is. So I'm going to make the opacity n over 10, and now we can see that the ones that have more terms are also more opaque. So this is not, I'm not expecting anyone to be able to make this graph immediately, although maybe some of you can, but mostly just to show that one of the things we try to do in here is make it so that if you try something, it'll hopefully work, even if the thing that you're trying to have it do is relatively elaborate.
A quick question on the parameterization. Can you parameterize colors yet, or is it just things like opacity?
You can parameterize colors. I love that question. Let's parameterize the colors. So awesome. Here, instead of the opacity, I'm going to set all of these to be opacity 1, just so that we can see what we're going to do with colors. We recently, very, very recently, so if you hadn't found this, it is not your fault. It's because it's 4 days old, made it so that you can define colors and then parameterize the colors. And so we support 2 different color spaces for this. We support the RGB and also the HSV color space. And I'm going to head over here and show you how these different color spaces work. So I'm going to define a new color. HSV, it's hue, saturation, and value. A horribly named third parameter because all of them are values. I don't know why they chose that. But what these do, saturation goes from like fully saturated deep color down to just gray. And then value goes from really, really bright to black. So these ones feel like they're very similar, but they're not. Okay, so I'm gonna make this. And then hue takes you all the way around the color wheel. It's 360 degrees, where 0 and 360 are both red. And as you go through, here's our purple, blue, green, yellow, orange, and red, like this. And so I can have a slider for that color. And then I can also make this a list if I want to. And so that's what I'm going to do here is I'm going to go 0, 36 up to 360. And now instead of a single color, I get a list of colors. So if I come back here, and let me just plot these in here. I'm going to do the same thing that I did where n goes from 1 to 10 by 1. Wait, no, that's not what n did. N was a full list. No, I'm going to go the other way. We're going to bring this color that I defined over into this graph. So I'm just using copy and paste for this. And I'm going to have the hue be, let's just do 36N. So that'll have the same effect. And here I can make this much brighter so that we'll be able to see it. And now if I go into the color for this thing, in addition to the 6 Desmos colors, I also have this new color swatch that I've defined. And so each one of these branches is now going to be a different color of the Desmos.
That's awesome. I think that's done in a really elegant way.
Thank you. I appreciate that. It took, I don't even want to tell you how many hundreds of hours to both design and then build it. So I am here that you like it.
It's something that I've been missing because I'm used to the hidden grapher app on macOS, which has a bunch of great features. It's in need of a lot of UI updates, but this emulates the recolor selected curves feature really well, and it does it in a way that's honestly better than it does that. One more question too. Do you have any plan for supporting native complex number types in the roadmap? I mean, beyond just the algebraic representation, but perhaps something like supporting holomorphic functions in general?
Yeah, that's a really tricky one. It's not on our short-term roadmap for the primary reason that most of our usage is in K-12, and that's where we focus. And so we haven't had a ton of demand for it. But as you can tell, our team loves stretching off past what you conventionally see in the K-12 curriculum. The reason that one's a little tricky is that the way we're able to make Desmos so fast is that we do a bunch of reliance on native JavaScript mathematical functions, and that's how we're able to make all of it crazy fast. The way that our parser compiler works is nuts, but it will compile all of this down to a set of JavaScript functions that can be executed per branch. And so it's able to be system optimized by all of the browser's just-in-time compilers. And as soon as we start to mutate what plus and times mean, those kinds of performance optimizations go away. That said, we really, really do want to do it. It's just not one that's on our short-term roadmap because it is both quite difficult to make fast and not as useful for our K-12 users.
I do really like the parameterization of the colors because it wasn't quite intuitive, and so I like the way that you can actually define a color and then insert it in yourself. That was really slick.
Here's a question on the colors. Can you use the colors to parameterize a heat map, or would that be something down the road?
So yes and no. That one you can't define a color by X and Y coordinate, and so you couldn't have a polygon and have it shaded based on that. But you can do things like make a list of points and then have every point have a color that is defined by its coordinates. And so then you can plot a whole bunch of points. And people have pushed limits on that way past what we anticipated. One of the interesting challenges that we've run into that's also been so exciting is that we're in this kind of arms race with our users where every single time that we make a new feature possible or every time that we make the graph a little bit faster, people will make graphs that push it past what we intended. So the first version of this, we expected people to graph no more than 10 equations because that's what you can do on a handheld. And someone graphed this 130 equation graph that must have taken them forever because it took us 30 seconds to just open the graph in that version of our parser. And so as we've run into those, we make it much faster. And we're like, no one's going to make one bigger than 500 equations. Let's make sure it's good enough for that. And people push the boundaries on this on a daily basis. The biggest graph I've ever seen computer generated was 40,000 equations, and it's still loaded. The biggest graph that I've seen with someone manually typing in every single equation was 8,000 equations. It took them 6 months. And that one also we're able to render. And so with points, that was one of those features where someone was like, oh, amazing, I can write a Python script. It'll generate a grid of 40,000 points, each with a custom color. They plot it. It takes a little bit while for the computer to graph it, but it is able to do it.
Do you
Awesome.
handle 3D graphs?
That's another yes and no. We don't. But people have built a number of 3D graphers on top of Desmos. I can show you one of the recent ones that someone made that just blew my mind. This one is not a 3D graph, but they're using these custom colors and they plotted a grid of points. And then they added in this like fuzziness so that it looks like it's further away from the graph with other points. And then using this hack that I didn't even know we were going to support, they made it so that you can click and drag to pan around. And so you end up with something that behaves quite a bit like what you would hope from a 3D graph.
Is there like a polygon behind that you're clicking and dragging and it's like hooking off that point somehow?
So you'd think so. Polygons aren't draggable, but images are. And so the thing that they did was they put a transparent image in the front, and we added this ability to make images draggable. And then as you drag it, you can watch these coordinates change as I drag this around. And so you end up, like, it's way smoother than I thought was going to be possible. And people have used this to build, general 3D plotters inside of Desmos. This one, they just wanted to show the full color space. We don't have a native 3D grapher, and I really, really want to build one. That falls into that same category. If it doesn't show up that often in K-12, it's going to be really hard, and we're probably going to do it anyway, just because it would be way too much fun.
I'm guessing vector fields also and phase planes also fall on that, right?
Exactly. And all of these are in the category of, like, you do a search for vector field Desmos, there's going to be a few dozen.
Someone's implemented it, yeah.
Exactly. And so here's like a general purpose vector field where you can even change what the functions are, and it's going to update in real time, but it's not a native feature yet.
One question I wonder about is when you want two graphs on the screen at one time that are not maybe even on the same coordinate system, how do you typically handle that? Or is that a situation you run into very often?
Yeah, that's a fun one. And so this is where we probably graduate from the graphing calculator into either using our API to put two graphs side by side, which you can do, or the tool that we've built for our internal use for curriculum that lets you do this kind of thing. So like side-by-side graphs. This would be part of a much longer conversation and demo, but this is the tool that we use for authoring curriculum that a student would work through. And this lets you do things like have two graphs side-by-side. And so on this one, we can have our function, and on this one, we can have our derivative function. That's if we wanted to, and then in preview, you see these side by side. And there's ways that you can connect these together and that kind of thing. We won't have time to get super deep into this platform, but it's basically a way to have multiple components on a screen, to have them talk to each other, to say when someone does something over here, adjust over here, to put in prompts. Here is the graph, and here is its derivative like this. And now we can have this kind of setup as multiple choice questions, those kinds of things. One of my dreams eventually is that all of the Desmos item types that are in Learnosity could be backed by this instead of just the kind of simple item types that we have that are backed by a graph, so that you could ask more elaborate questions and give more interesting feedback. But yeah, that's the short answer for side by side.
So is Activity Builder currently only used internally by your team?
Yeah,
Yes.
It's used internally, although we are just starting to package it up as an API in collaboration with a major publisher that we're working with, a company called Amplify. And so at some point, I would guess in the next 6 to 9 months, this API will be available in a similar way to the calculator API. I think that's going to open up some fun doors. That's my hypothesis. Because more or less what we found is that the graphing calculator as a tool is just like a wonderful free-form tool as a way to ask questions where you're trying to evaluate if the student got it right. It has some limitations that make us a little bit bummed. Really, the only way that you can interact with it is through points that you can drag around, which gives an enormous amount of power, as you've probably seen in some of the questions, but nowhere near the flexibility that we would want. There was a question that came up earlier about what kind of subject areas is this good for, where the obvious areas are, algebra and calculus and algebra 2 and pre-algebra, those kinds of like Cartesian grid-based things. But as soon as you start to use it inside of activities, the scope that it's useful for expands pretty dramatically. And so we're using it in geometry, we're building out middle school math is where we're starting, and lots of places where you can't even really tell that the thing that's going on in the background is a Cartesian grid. There were a few different features in statistics that we really wanted to be able to support. The first one was things like tables of data and then regressions. And so this is a feature that we've had for a little while where you can make a table, this kind of thing here. And let's make this all a little bit bigger. And then what we wanted was to be able to let you run a regression against this data. And so we've had a feature for a little while where you can do a regression using the same syntax as something like R, where you do, instead of an equals, which is an assignment, you do this regression symbol, and it will compute all of the free parameters and give you a best fit model. Like all of the other things in our system, we've tried to make this extremely flexible. So if you wanted to try a proportional model, you would just get rid of the plus B and it'll find you the best proportional model. If you want to try changing the data, I can come into here, make all of these points draggable, and then the model will update as I change the data. So this was one piece of statistics, but the other things we really wanted to support were things like histograms and box plots and dot plots and distributions like the normal distribution. And so I'm just going to give you the very, very quickest overview of those. Let's start with a normal distribution. So to do this, we're going to say something like normal dist. It defaults to a mean of 0 and a standard deviation of 1. Let's assume we're selecting people and we think that the average height is, 78 inches with a standard deviation of 6 or something like this. We can press zoom. We've now got our normal distribution for people. And so we can ask these questions like, what's the chance that someone is between 70 and 90 inches tall? And we can read that off of here. We can find it with the CDF. But the other thing that we wanted to do with this was to make it so that you could do things like random sampling from this distribution. And so this also supports things like I can assign it to a variable and then I can ask it for 100 random samples. I'm just going to make a quick histogram of that set of values and make it a density histogram. And so here we've got a random sampling from this population and we can re-randomize it to get different random samples. And so this is kind of the foundation of our statistics package. All built into this tool is that you can do things like define different distributions and then sample from those distributions. The combination of these hopefully is a really nice setup for students are creating this when they're doing statistics in maybe 10th or 11th grade. But even when you're starting to get introduced to it earlier, there's a ton of room to have the teacher set this up in advance and then have a student just manipulate and then interpret the results. I remember the thing that I was going to show. We're not out of demos yet. There was a question about accessibility, and I want to talk about accessibility. Before I do accessibility,
I asked about statistics. I also asked about the accessibility with regards to graphs like this and statistics. How do you handle that and how it operates?
Gotcha. I actually have no idea how statistics or how accessibility is going to do with this histogram. So I'm going to pretend that I didn't hear that part of the question, but you can try it. I'm going to show you how it works with other parts that I know how they work. So let's do just a very quick accessibility demo. So one of our big focuses as a company has been around accessibility, especially for vision impaired and blind students, and the WCAG standards. We go very, very deep on those. 2.1 AA is our target. But we've also gone quite a bit beyond the WCAG standards. And so things like, the contrast that we choose and making sure everything is keyboard navigable and a set of keyboard shortcuts all built in are targeted at these WCAG standards. But we wanted to go past this and especially to focus on interpreting graphs, which are so visual as a vision impaired or blind student. So here's the feature that we built that I'm quite proud of, which is that on any curve like this, you'll see that there's a button down here with a little music play icon. And this lets you enter into audio trace mode for a graph. So if I do this, I can press this button and it will actually play the graph as sound. Okay, so here I can listen to this graph. And then we can play around with what happens if we change some of the parameters here. So, you can guess what that one's going to sound like and this is what it does. And there's a set of kind of subtle cues that we've put in here, like when it's a negative value, we made it sound a bit like it's underwater. So we add like a little static. When it crosses this axis, we add an overtone so that you can tell that it's now a positive X value. So there's a ton of stuff like this, and we can share over all of our docs on it. Goal was to make it so that a vision impaired or blind student could use this tool as effectively as a sighted peer. And I could go on forever about those features because I'm crazy proud of them. All of our accessibility work is led by a blind engineer on our team named Steve, who's just wonderful.
Has anyone ever tried to make like, I know it's for accessibility, but now I'm wondering about the novelty of it. Has anyone tried to make a song out of that?
Yeah, we've actually gotten a number of them. I can maybe pull up my favorite.
Can you do multiple at the same time? Because that really opens up a lot of possibilities.
Yeah, we actually made it so that you can't do that.
I feel like it would be chaos for accessibility reasons. Like you wouldn't want to hear multiple graphs at the same time.
That's exactly right. Yeah, it's too bad because for musical reasons, you totally would, but for accessibility, you wouldn't. Here's a graph that a 13-year-old made, and it's Flight of the Bumblebee. They did the entire song. It's really, really nuts. Yeah, we've seen a fair bit of that. And we've seen in a lot of classrooms where teachers are encouraging students to use this even if they're not vision impaired or blind, because there's some really interest, like when you're introducing slope and the idea of like a positive slope versus a negative slope, and they look really similar, but they sound so different. And so it's a great way to build up an intuition through just connecting with another representation.
What are the things that are unique to what Desmos, what kind of things do you hear from teachers that where you're getting really positive uses of this?
So there's a couple different products at Desmos, and they're used in really different ways. And also we're seeing, and I'm sure you're seeing the same thing, the way folks are using Desmos right now is so different from a year ago. It's both this like, I feel so lucky that Desmos is a helpful tool during the pandemic, and like so sad that people are forced to use Desmos the way that they currently are. So conventionally with our calculator, it gets more usage historically than our activities. And we see 2 spikes every single day. So there's like during the school day, and I think there's a whole bunch of, we're introducing a concept, like take out your calculators and play around with it. And I think it's when you normally would have asked students to take out their TI, but also a number of examples past that because it's so exploratory. And so they'll say, type in this equation, drag this slider, what do you notice? Like what's happening with this? We see, and then we see another spike at night when kids are using it, I think, to just help with homework or check homework. We see a set of projects that we really love. Some of them are strictly art, kind of like that Bumblebee thing that we just saw, where they'll say, you know, hey, you just learned about conic sections, like draw your favorite sports team logo using what you just learned. And kids get really, really bought into that. So with our calculator, it's a combination of those kinds of things. It's like practice, homework, instruction, and then these kinds of projects. All it used for each of those, I think, more than we anticipated. With our activities, we designed it to be used, you know, once a week, once every 2 weeks. Like here's a fun lesson where a teacher can track the work of the student, except for now the curriculum that we've built where we've got an activity for every single day. What we've seen over the last, 12 months, 8 months, I guess, since the pandemic hit, is teachers more and more using it every single day. And so it's just like, here's the thing that we're learning today, and they make a lesson, and they've got these, either it's stuff that we've built or they've built. And the numbers for that are kind of staggering. Like usage has gone up 4x since this time last year of that kind of use of everyday use. We expect that that'll go back down. The like CEO in me is sad that that'll go back down. The like educator in me is so happy because I just know that people using it in that way, it's out of desperation, not out of like, this is the right way to teach. And so I'm just excited for the world to return to normalcy.
One question about the activity builder. One of the ways, so a number of the tools that we create when you're in a rich text editor, you can drop in a tool, right? And that's one of the ways that I've kind of talked, some of the conversations I've had with you and others there about us enabling for the LMS. Whereas the activity builder seems like you're almost recreating a content building environment, which has its strengths, right? Because you can control so many aspects of what's going on. So I wonder if you can comment on your approach, and are there other environments where you have this other approach which just says, hey, if you want to drop in a graph inside of some rich content, you can do that, and towards this effort of creating an interactive curriculum.
Yeah, it's such a challenging trade-off. Because you're right, the calculator is just like wide open in flexibility of what you can do as long as the thing you want to do involves graphing stuff. Then you can do anything. It's just this playpen. Once you get inside of activities, it's exactly like you described, where like we set out the components and we pick them carefully. We're like, on this screen, it would be helpful for you to have a table and to have it be partly filled in. And on this screen, it would be helpful for you to have a free response. And we haven't figured out a good usable way to build kind of a general purpose, show your work for students. You know, I want to put in a graph and I want to put in a different graph and I want to, that kind of thing. I'm really, really excited about that premise. Have not figured out a way to make it work well. And this is both, you know, just the raw mechanics of the usability of adding the components. And we've seen some examples of attempts, none of which has really impressed us from a UX perspective. And then there's deep questions about how that works with accessibility. Like when you've got something that requires such a visual layout, drag drop kind of interface, how does that work with accessibility is an additional challenge. So that was a long-winded way to say, I'm excited about that. I have no idea how to do it. I would love to figure it out someday.
And it seemed like your response was kind of focused on a student being able to drop in graphs as part of writing a solution. But what about the other approach of instead of like requiring people to use your activity builder, but instead saying, okay, use a rich text editor, which lets you do whatever you want. But anytime you want a graph, here's how here's a button to click to drop in a graph.
Yeah, I'm interested in it. And I think the closest example that we've seen to that, and people really like it, is Equatio. I don't know if you've seen this product. It's like the Google plugin. And it's pretty much that. You know, they've got their freeform space and you can drop in as many Desmos graphs as you want. And people love it, I think. So it's compelling to me as a premise. And that's actually probably also the best example I've seen of the kind of ideal user interface for that.
Do they use LTI Advantage and deep linking for that integration, or is it doing something different?
No, they don't. So that's an example of one where they use our just like raw JavaScript API. And there's a number of huge advantages to that when you use that. It's like self-hosted. It doesn't talk to our servers. There's no student data exchange. There's no kind of latency as it tries to hit our server. But it also means that the application is like there inside of a DOM element. So it takes more work to set up, but that's how they built that one. For those kinds of applications, LTI feels like a little bit too kind of boundaried and sequestered to be the ideal way to put them together. For other things, like that's I think what LTI's big benefit is that like you don't need to have as much trust between the applications, that kind of thing. What do you
I am curious, have you guys looked into WebAssembly or anything similar for performance?
Yeah, we have. So one of the fun things is that at least the way that we are using JavaScript, you don't get a huge advantage from those. Like the jitters have just gotten so good at the types of things that we're asking them to do, which is like repeat a JavaScript call 100,000 times, that they get native performance. Like we outperform naively compiled C for all of the mathematics that we do, and we're comparable with kind of carefully compiled C as well. There are places that we want to improve performance, and a lot of it is actually at rendering as opposed to at computation. And so we're looking more and more for some applications into things like using WebGL. This is definitely what we need to do if we wanted to get into 3D, but we think it could be helpful for some, like implicit plotting is another place where it just gets really heavy because you have to do it per pixel. But yeah, really just at every single moment, probably someone on our team is trying to work on making Desmos faster, because I feel like that's such a competitive advantage of ours.
I just wanted to thank you so much. Looks like we're about out of time, but I really appreciate the time you spent sharing this. You've made me smile many times in this presentations, and I'm sure it feels gratifying to do this good in the world, which is what I really believe that you've done. So thank you.
Thank you to everyone here for indulging this monologue for the last little while. It's been a real joy.